What would you do if you woke up in the middle of the night and it was freezing cold in your house and you realized your furnace wasn't running? Well, like most people, you probably have to suffer through the night and in the morning call an HVAC tech and hope to get someone out to your house as quick as possible. But what you can also do is watch this video and learn a few simple techniques about some common problems that will prevent your furnace from either firing up or from continuing to run, and you can fix the problem easily yourself. Stay tuned. Well, before I show you the troubleshooting techniques that I use for determining what the problem with my furnace is, first let me just kind of give you an overview. This is a 80% gas furnace. You know that because it has a single metal exhaust going out of it. If you have a 90% furnace, you'll have likely two PVC pipes coming out, one for fresh air and one for exhaust. But either way, this is a gas furnace, so what I'm going to show you is how to troubleshoot gas furnace issues. But before I do that, we need to understand how it works. So on a typical gas furnace, you'll likely have a switch on the outside and a gas piping going in with some kind of shutoff. So, the first thing we're going to do is just determine, do we have gas on? And we do. The handle is parallel to the gas flow. If this was turned like this, we have it perpendicular to the flow, which means it's off. So we need to make sure our gas is on, and we need to make sure we have electricity going to it. Now, I'm going to try to show you troubleshooting techniques as if you were a homeowner without any specialized tools, but one thing you could do is buy like a $10 voltage detector, and you can determine whether or not you have voltage going into your furnace, for one, and also, you can make sure. I have the switch off now, but that, you can at least check to make sure you have voltage going to the furnace and your gas is on, and that tells you that this should be working. Okay, now with the panel open, we can continue a little bit more troubleshooting with regard to our power here. So what we can do is take our voltage detector and see if we have power coming in from the wires here that are coming from the switch. So as you can see, there is no power coming in, and that's because the easiest thing to troubleshoot is our switch is off. Okay, so now that we know there's power coming into the furnace, let's look a little bit further. Most furnaces have what's called a main board or a control board, usually at the bottom by the blower motor if you're in an upright furnace like mine. And we know that we have power coming in, but yet the furnace still isn't running. So one of the things we can do is kind of trace down the wires that come down to the main board. We should have a wire going into the board. One of these black wires should have power to it. But what's really common is, and some mistakes homeowners make, is that when you open the doors on the furnace, there's almost always a door switch that is also cutting the power off as a safety mechanism, so if you have the doors off, the furnace won't run. And as you can see, that's right here. So what you could do when you're troubleshooting and you want to see the furnace run without the doors open is you could tape the switch down, or what I like to do is I always keep a clamp, one of these little clamps in my bag, my tool bag, and I can clamp that switch closed so that we can do further investigation on the furnace while the doors are open. So once I clamp the door switch, I could see not only, if you look at this black wire coming off of the switch, that now has voltage, this black wire right here, but you can also see that once I engage that switch, the status light of my board is now showing that it has power. One thing I also mention is the furnace board usually has a 3 or 5 amp fuse on it, so that's always good to check if you're not sure if it has correct power. And as you can see on mine, it's kind of hard to see there, it's at the bottom. I'll just go ahead and pull it. They're just like the automotive style, most of the time they're automotive style blade fuses. and this one happens to be a 3 amp fuse. And oftentimes you can buy these at the auto parts store.
Here's a comparison of two fuses. The one on the left is blown and the one on the right is good. To know if it's blown, if you look in the middle part there, you'll see there's not a clear connecting wire, and instead there's maybe a black spot, as opposed to a new fuse where the wire is perfectly intact.
So if we get to this point, we know that we have power and gas and everything coming in. We know that there's power coming to the board, but the furnace still isn't firing up. The most likely candidate, I mean, it could be a bad board, but more likely what the problem is the thermostat isn't calling and telling it to provide heat. So at this point, make sure that your thermostat's on, it has fresh batteries, and that you have it set to heat, and then you have it set to hotter, the temperature hotter than the room temperature. If that's all true and the furnace is still dead like it is now, then what we could do is test to make sure or confirm that it is in fact our thermostat that's not working. So the way we do that is we're going to focus down here on our board. So see these this grouping of wires here? These are your thermostat wires. There's going to be letters next to each of these terminals here. And typically wire color also to kind of give away what these should be. There's kind of standards to what wires you should have. There's a green wire that's ground, and that's kind of a standard industry thing. We have a red wire that's going into R, so that makes sense. And then typically you'll have various other colored wires, but the one for heat is typically white, and it goes on the W terminal. So this is white, and then we have our red. Now what the thermostat does is when it calls for heat, it basically just connects red and white together. And that's what switches on heat. So we can mimic this. I just have this little, I always keep these in my little toolkit here, but you could just have a little piece of wire, and you know, that you could just touch the red and the white and just see if that turns the furnace on. That will tell you that the thermostat's what the problem and it's not working. So I'm just going to do that right now and see if we hear it come on. And you can see, I'm going to turn it off now, you can hear that the inducer fan starts coming on. So we know that the problem is our thermostat is not properly making that connection, and we can go to Home Depot and buy a replacement thermostat or replace the batteries in it, and that should take care of our problem. Okay, once we know that the furnace is capable of coming on because we've ruled out all the possible issues of power or thermostat issues, and it still doesn't quite work right, let's talk about the order of operation of what this stuff does, and that will help you troubleshoot any of these other common problems that we could have. So let me just kind of really quickly explain what the parts are and kind of demystify this whole thing. You'll typically have a motor at the top here that's connected in some way to your exhaust. Now, if you have a 90% furnace, this might be a PVC pipe, but either way, you'll have a motor, a small motor around here that pumps out exhaust, and that's called the inducer or draft motor. What it does is it induces a draft. It's just a motor that spins into the squirrel cage here and pushes exhaust air out. Well, the purpose of this is to provide draft to our burners so that when these things fire up, it licks the flames like a jet into the heat exchanger. Without this draft motor, what would happen is it would look like an outdoor gas stove where, you know, it would just be, this box would just be on fire, and that would not be helpful, nor would it be safe. So the first thing that should happen is this motor should start up. Then what happens is, after this draft motor is going for a second, this right here, you might have, you can see I have two of them, a primary and a secondary, which is common. These are called pressure switches, and this tube here is going into this little port, and it's basically, once you create this motor creates a draft, it will suck in on this tube, and these switches will close. These switches are hooked up to the board through this wiring here. That will confirm to the board that we have inducer draft. So once we have inducer draft, then the gas can start up. Now, notice that from my gas feed coming in, I have gas pipe coming into here, and it comes into a contraption that looks like this. This is called a gas valve. The gas valve is simply there to open up and let the gas, whether it's natural gas or propane, flow through. So it comes in here, the gas comes in here, and here's the valve, and then here's the output tube, and that, if you follow that, that goes to the burners. This is opening the gas. Now notice that there is also a switch on here. And it's not as common, but you know, if someone was to fool around in your furnace, like say a technician, and it wasn't working again, it could be that this is off. But that's not very common that, you know, you would ever turn this on or off. But make sure that's on. And then the gas will come in, and then what will happen is now we're ready for ignition. Now there's a couple components here to ignition here. The first one being, if you trace the tube out of the gas valve, you'll notice that it hits one of your combustion jets first. Now notice behind there, the difference between that jet and a lot of the other ones is it has that little apparatus there. Do you see that? And I'll show you that in a minute. That's your igniter. So the next thing that's going to happen is gas is going to start flowing, and then that thing is going to glow red hot to ignite the gas. Another version of that igniter, that's the kind of a tungsten glowing type where it heats up. Another type, you'll hear a ticking sound, kind of like one of those gas grills, where it creates a spark, like an electrical spark. But either way, you should see that thing glow or a ticking sound, and that should spark the gas and ignite it. Once it ignites on the first burner, that flame will spread in line to all the other burners. And the last burner will almost always have this guy right here. And there's like a little metal rod going down there, and that's called a flame sensor. And it's specifically on the last one because it's detecting if there's a flame or not, and on the last one to make sure that it's all the way at the end and we have all of our burners firing. Well, if there is no flame, then that will tell the board, that flame sensor will say, then don't run. And the reason for that's actually obviously safety. If we don't combust our gas, then we just have a gas leak, and that's bad. So that will tell the board to shut off the gas valve because we don't have proper combustion. So that's a common component, and I'm going to show you how that works and how to clean that, because that's a very common problem with furnaces shutting off and not operating properly. Okay, so at this point now we have full combustion. We have our flame, a sensor detecting a flame. The next step is down at the very bottom, and that's the blower motor. And now the blower motor is going to fire once it knows we have combustion, and once we've heated up the chamber to get to a proper temperature, then we can start blowing the air. Now the blower usually on an updraft furnace starts at the bottom, and it blows the air up in the back of this heat exchanger here, and up through the plenum, and then distributes it out to the different ducts. So that's essentially how a furnace works. Not too difficult. So let's watch this thing in action. Okay, so I turn the furnace off. Let's go ahead and get our jumper. Always turn the furnace off before you jump it out, just to make sure your jumper doesn't short out, because if this falls against sheet metal, then that red will ground out. So trying to do this one-handed here. It's not very easy. Okay, so now that that's secure, let's go ahead and turn it on and we'll watch the operation. Okay, so first thing you should hear is the inducer draft motor clicks on. That clicked that proof switch. Now we should see our gas start turning on, and we'll see our igniter starting to glow. Okay, that fired the first burner, which spread the flame to all the burners, and now we have the flame hitting our flame sensor, and so everything looks good here. So the next step should be that once we get to the right temperature, our big blower motor should start turning on. So let's give that a second. Heard the relays click. And here comes the blower. And there we go. Now we have the blower motor running and we have heat coming up through our plenum. Okay, so at this point we know we have power coming in. We know we have gas and everything like that. So let's go back to troubleshooting here. We've got power, we've checked our fuse, we have the light on our board. It's, you know, we've got our indicator light. So everything looks good, and that we know we've jumped out. Let's say we've either jumped out our thermostat or we just know our thermostat's calling for heat, but nothing happens. Again, let's go back to the beginning. What's the first thing that fires off? Well, it's the inducer draft motor. What we need to do is investigate that first piece. If that doesn't come on, then we know the problem starts there. We have to have draft before anything else fires up. The two common problems if that does not fire at all is either that motor's bad or the board is bad. The way you can maybe make a determination of that is this motor has some wires coming into it, you know, usually like a red, white, or red, white, and black. What I would do is take my non-contact voltage tester and see if there's any power going to these wires. If everything is lit up and it's calling for heat, you should have full line voltage, meaning 110 volts. That's typically this motor runs at full line voltage going into this. So if you touch the black or red wire, I don't know which one it is, but it should light up your voltage detector. Now, if you have voltage and this thing still isn't running, it's likely that that motor went bad and that needs to be replaced. Not a very common problem. Usually these inducer motors do last the life of the furnace, but I certainly have seen it before. So now let's say this motor starts up, but nothing else happens. We don't get flame or anything else happens. The typical problem there could be that the draft switch is not closing to prove to the board that this thing is creating a draft. So there's two potential problems there. One is that if you notice that this is physically using a rubber tube onto a port, sometimes you'll see two rubber tubes, like each switch is independent, but in this case it's one rubber tube split in between the two switches. The most common problem there is either this is clogged, because literally if this is clogged up, this can't provide the suction in order to physically close these switches. Very common problem is this inducer port gets clogged with debris, because remember this goes all the way to your chimney, and I've got a 100-year-old brick here, which means it's probably pretty dusty in there. That dust can collect and solidify inside this inducer port, and so I just need to clean it out. Let me show you how to test that. The way I'm going to troubleshoot this, I'm going to pull out this the soft rubber tubing off of this little port here. Just be real gentle. It should come off. And then what I'm going to do is, I'm trying to do this to where for homeowners that don't have special tools. So the really low-tech way of kind of seeing if it's your pressure switch is, and you may not like this, but I'm going to just suck on the tube with my mouth and listen to hear if I hear the switches click. You hear that? Let me see if I can get the camera real close so I can get the audio. When I suck on it, I hear those switches clicking, which tells me they're probably working. But usually the problem is not with the pressure switch failing, although it certainly can be, but it's usually this port, like I said, this port getting clogged. So what I like to do is take a little piece of wire or anything, with a, thin enough that I can get in there and notice, you'll hear it. Actually, it really needs to be clean because I hear crunchiness in there. So if it's real crunchy or plugged up, you should be able to basically put this wire about an inch up into there. So where it's actually going up into this chamber here. And yeah, I actually can hear a little bit of crustiness, so I think it did need to be cleaned a little bit. So that usually will take care of this problem. And believe me, from experience, I've woken up in the middle of the night and it was a clogged inducer port that kept this from firing. And again, all I did was I watched the furnace start up. I listened and saw the inducer motor start, but yet nothing else fired. And that usually is a telltale sign that your inducer port is just clogged up with some debris and you just need to clean it out with a bit of wire. Okay, so obviously the next thing that we need to address is, now that we know our inducer motor and pressure switches are working, we need to come back and look. Now we're looking at the gas valve. So the next thing we want to see that should happen, since you can't really see gas, I mean it's, or really hear it, the next thing you want to do is look to see if that igniter either clicks or glows. Like I said, it's depending on the type. You should start seeing that thing glow. So what happens is, if that doesn't glow or that doesn't start clicking, then likely that part is probably broken, and that is a consumable part that is typical, needs to be replaced. Now on those tungsten style, the ones that glow, typically if there's like it's just held in by a screw and a couple wires that you can unscrew it and unplug it and carefully pull it out of there. I'm not going to do that now, but typically what you'll see is you'll see a crack in that element, and then you'll know that that's bad and that's the problem. So if that doesn't glow, or that doesn't, that your igniter doesn't start glowing or clicking, then you know the igniter's the problem. Okay, so what happens if that glows, but then nothing happens? You get no flame. Well, can typically be a gas valve problem. So again, make sure the gas valve is on. No one was monkeying with this. But really, troubleshooting a gas valve is outside of the scope of this. That's a little more in depth, than making sure you have voltage to it, which is low, typically a low voltage, the 24 volts. So that will be a little more in depth. I'm not going to go into that here. But yeah, typically if you get glow or ignition, your igniter is clicking or glowing and it doesn't fire, it's typically a gas valve problem. So that may be more in depth, and that maybe you probably should call a professional for that. Okay, so now we've got past that. We've got glow, and then we have ignition. Another very common problem is you'll get ignition, the flame will ignite everything, or it'll ignite this burner, but let's say maybe the fire doesn't spread all the way to this last burner, and then everything shuts off. If you don't see the fire spread across the burners within a second, then it might likely be these burners are dirty. And typically what you would do for that is if you can, take these burners off by undoing those screws and just clean them out with a nylon bristle brush. Because what happens is these burners are shaped such that when one burner fires, the fins spread the flame to the next one, and if those fins get dirty or clogged up, the flame may not spread across. So that's just a matter of cleaning these little burner deals off. Now, let's say you get ignition, it spreads across all the burners, but then after a couple seconds, everything just shuts off. And this is a very common problem, and this has happened to me on this furnace as well, and that is one of the most common problems of any furnace is everything starts up, all the ignition fires, and then after about 2 or 3 seconds, everything shuts down for no reason. That's usually the flame sensor. The flame sensor is either dirty or it's bad. And so that's a common maintenance problem. So the next thing we're going to do right now is clean that. So to clean the flame sensor, it's actually pretty easy. You need just, in my case, a Phillips head screwdriver, because there's just a Phillips head screw holding this thing on, or maybe a 1/4-inch nut driver. Those are the two most common fasteners. Sometimes mine is, in this case, it's really easy. Sometimes yours might be hard to get to. If it's easy to get to, then the best way to clean it is to simply just unplug it, and let's see if I don't try not to get in front of the camera here, but I'm just going to unscrew it, take the sheet metal screw out, and I'm just going to pull it out carefully. And now you got to be a little bit careful not to scratch it, because if you scratch it, you'll also damage it. Now, mine I keep clean every year. I do this as just a maintenance, just because it's so easy to do. And the way to clean it is just take just a little piece of mild steel wool and just clean it with some mild steel wool. I've also heard techs, if you're missing your steel wool, you don't have it in your kit, will take a $1 bill. Anything that's just mildly abrasive, no sandpaper, nothing with heavy abrasive, that'll ruin it. But just something mildly abrasive like steel wool or even a $1 bill, and clean off any of the junk on it. And that's usually will take care of that problem. Make sure when you put it back, you reinstall it, you're just careful not to scratch it against the metal. So just carefully drop it back in there and just try not to scratch it. Okay, well, now that we've got to this point, we have flame, we have inducer draft, we have all that stuff. But what happens if the last part of the process, which is the main blower motor, that does not, you don't hear that starting up? Well, the most common problem there is the blower motor could be bad. Usually what you'll start hearing is whining or squealing, like the bearings are going out. The other thing that could be out before you go ahead and replace the whole blower motor is the run capacitor on the blower motor. I'm not seeing the run capacitor on mine. This might have the run capacitor built in inside of that motor assembly there, but sometimes you'll have the capacitor running into running in between the wires of the motor and the board. There'll be some sort of capacitor, usually mounted on the tin somewhere around the motor. If you have one of those, that may be the first thing you want to replace because they're much cheaper than the actual motors themselves. Otherwise, you might have to replace the motor. That's it for the furnace troubleshooting. I'll just back out a little bit here and just go over kind of what I do real quickly for maintenance. So for maintenance every year, I replace the filter, which on mine is this right here. Your filter might be in a wall or it might be attached to the side of the furnace. You know, the filter is just to prevent the blower motor from pulling in dirt and dust into the motor itself. So if you know where the blower motor is, you know that the filter is either right there in between your fresh air intake, or it's probably maybe in the wall somewhere right by the intake. You guys probably already know how to do this. Just check to see if you have the right size based on the old one. So mine's a 16 by 25 by 1. You might have one that's 1 inch, or it could be 4 inches thick, could be inside of a door thing, whatever. But yeah, always make sure you replace that a couple times a year. Also, they have an indicator for airflow. You can see that the airflow is going into the furnace, which makes sense, right? Because it's pulling the air from your fresh air intake into the blower motor and then up and out your duct. Those are the three things: is furnace filter, flame sensor, which I just showed you how to clean, and the inducer port. If you keep those things clean every year, you will likely have no problems with your furnace for a while. Well, thanks for joining me on my annual furnace maintenance. Now that I've got it all buttoned up, I got the new filter in, we've cleaned the flame sensor, we cleaned the inducer port, and I set the thermostat to call for heat, so I'm going to go ahead and turn it on. And we're running. Now we're good for another season. If you have any questions or comments on your furnace, please leave them below and I'll get back to you. Thanks for watching.